Hi, I am Dr. T.V. Haimlakshmi, working as an associate professor in the Department of ECE in SRKR Engineering College. In this lecture, I would like to discuss about the image compression model. In this image compression system, composed of two distinct functional blocks, those are the encoder and decoder. If the device having both encoder and decoder in a same device, that is called as the codec. Coding and decoding, that is encoding and decoding. In this encoder, there are three blocks, those are mapper, quantizer, symbol coder. These three blocks reduce the three redundancies, that is spatial and temporal redundancy, psycho-visual redundancy or irrelevant information, next coding redundancy. In- and the decoder having the symbol decoder, that is reverse process of this symbol coder, and the inverse mapper, that is the inverse process of this mapper. This quantizer is not reversible, it is irreversible, so there is no reverse process in the decoder. And the remaining two, that is mapper and symbol coder, are the reversible, so there are reverse process in the decoder. First, let us see this mapper. What is this mapper? That is the first block in the encoder. This reduces the spatial and temporal redundancy by changing that intensity values in a particular format. That is, a mapper transforms into a format designed to reduce the spatial and temporal redundancy. For example, in this image, all these pixels having the the same intensity values. That is, the intensity value of the that pixels are depending on the neighboring pixels on the same as the neighboring pixels. In that case, that all these pixels which are having the same intensity level are dependent on the neighboring pixels, that can be represented in a particular format. Suppose in this example, the pixel values, pixels of 1 to 100 having the same intensity level, that is 10. It can be, instead of representing all these 100 pixels having the 10 intensity values like that, 10 10 10 like that, for the 100 pixels, it can be represented by this particular format, that depending on that formats. For example, in this format, that starting pixel and end of the pixel and the intensity value. These 100 pixels can be represented that particular format. That is the mapper. If this operation performed by this mapper. So this mapper reduces the spatial redundancy in case of the images, or in case of the videos, if the frames having the same intensity levels with the neighboring frames, that then also it can be represented in the particular formats, that is the based on the that nearby frames. That is the temporal redundancy in case of the videos. In case of the images, that is the spatial redundancy. So this mapper reduce the spatial and temporal redundancy. That is the This mapper reduces the spatial and temporal redundancy. Next one is the quantizer. This quantizer reduces this psycho-visual redundancy. That means in most of the 2D intensity arrays contain information that is ignored by the human visual system. That is the irrelevant information or psycho-visual redundancy. For example, this image is represented by using the 256 gray levels. That that intensity values are quantized to the 16 levels in that two images. There is no variation. That variation uh, cannot be identified by the human visual systems. That redundancy can be reduced by this quantizer. That is the quantizing the that is the goal is to keep irrelevant information out of the compressed representation. That is the goal of this mapper. For example, in the image, having the intensity levels, some intensity levels of, for example, those that intensity levels are 19, 20, 21, 22, like that. It can be round off to the 90. It can be round off to the some value, for example, that is the 20. So all these intensity values can be represented by using one intensity level. Then the intense number of intensity levels in the image can be reduced, so that it can be round off or quantize the that intensity levels, that is the quantizer. So this quantizer reduce the irrelevant information or psycho-visual redundancy. But after rounding off these values, it cannot be reversible. We cannot assign the values after rounding of some value. For example, that is the 20. We cannot assign that whether it is 19 or 21 or 22 or like that. We cannot again do the reverse operation. So there is no reverse operation in the decoder. It is the irreversible. That quantizer reduce the psycho-visual redundancy or irrelevant information. Next one is the symbol coder. That is here, for example, in this image, it consists of the only few intensity levels. Instead of this, suppose it is the 250. There are intensity level. That image is represented from the 0 to 255. That is 256 gray levels. In those total intensity levels, there may be some some intensity levels are having this image. So that suppose, for example, there are only 10, some 100, 200. Only, for example, if the image having these three values, then we can assign the some codes. That is, less less number of bits can be assigned to the most probably intensity values. That is the symbol coder. That operation performed by this symbol coder. It generates some codes to reduce the coding redundancy. That symbol coder reduce the coding redundancy. That is the encoder. Mapper reduce the this mapper reduce the spatial and temporal. This reduce the spatial and temporal redundancy, and this quantizer reduce the irrelevant information or psychovisual redundancy. This symbol coder reduce the coding redundancy on coding redundancy. And it is the reversible. It is also reversible, and it is not reversible. Okay, it is the irreversible. After quantizing the intensity values, we cannot reproduce that previously assigned intensity values. So it is the irreversible. So this decoder performs the reverse process of this encoder, where symbol coder assigns the particular symbols, particular coding to the that particular intensity values. Again, here by based on that code, that is decoding to the that intensity values. That is the symbol decoder. In the inverse mapper also, here here represent the some formats. That formats are that decoded into that particular intensity levels. So we get the that decompressed image. Here in this encoding, there is a image is compressed by reducing the different three types of redundancies, and here that is the decompression. Then we get the what is the input is given here, then we get that output is, that is the compressed and decompressed image. That is the encoding and decoding. The decoder contains only two components, that is symbol decoder and inverse mapper, because these two only are the reversible process, and this quantizer is not reversible, so there is no reverse process in the decoder. A summary of this topic: there are three types of redundancies. Those are spatial and temporal redundancy, irrelevant information, coding redundancy. The mapper reduce the spatial and temporal redundancy. Quantizer reduce the irrelevant information or psycho-visual redundancy based on the fidelity criteria or the information having that image. That information can be measured by using the probability of occurrence of the event E. For example, that probability of occurrence of the event is the P of E, then information equal to log of 1 by P of E, that is minus log of P of E. For example, if the probability of then that occurrence of the event is 1, then it is the log 1. Then information equal to 0. Okay, next one is the that symbol codon reduce the coding redundancy. Thank you.